Hello everyone, myself Sri Vasudevan. I am from first year EC department in SVC College, Bangalore. Today we have to discuss about the topic transformers in introductions to electrical engineering. First, we know about transformers in electrical engineering. This presentation explores the vital role of transformers playing in electrical engineering, covering their principles, types, applications, and maintenance. Next, we move on to the introductions to transformers. First, we know about what are transformers. Here, the transformers are devices that transfers the electrical energy between the circuits by electromagnetic inductions, changing the voltage levels while maintaining the power. Then, key functions. They are essential for transmitting the power efficiently over the long distance, adjusting voltage for different applications, and isolating circuits for safety. Next, we move on to the transformer principles and theory. Here they have four steps. First is electromagnetic induction, next voltage transformer, power conservation, and transformer efficiency. Next, what are types of transformer? There are four types of transformers: power transformers, distribution transformers, auto transformer, and instrument transformer. In power transformer, high voltage, high power used in power generations and transmission. Distribution transformer, lower voltage used to distribute a power to homes and businesses. In auto transformer, single winding used for voltage regulations and phase shifting. An instrument transformer used for measuring current and voltage in electrical systems. Let's move on to the construction of transformer. First type, core. The material it is made up of laminated silicon steel sheets to reduce the eddy current losses and hysteresis losses, and it provides a low reluctance path for magnetic flux and support the windings. They have two types, core type transformer and shell type transformer. Next is windings. They have two types, primary winding and secondary winding. In primary winding, it is connected to the input voltage source and generates a magnetic flux. Secondary winding in this induces a voltage due to the magnetic flux generated by the primary winding. It- In material which is used for winding means high conductivity of copper aluminum wires. Winding are insulated to prevent a short circuit and withstand high voltages. Next is insulations to insulate the different windings. And fourth one, transformer oil functions. Provides the insulation between internal components, act as a coolant to dissipated heat generated during the operations. Types, mineral oil or synthetic oil. Fifth one, tank and enclosure. In houses, the core and windings protecting them from external environmental conditions. Then additional features for this, the conservator tank for oil expansion, cooling fans or radiations to enhance the heat dissipations. Sixth is brushings. It provides insulated outlets for the winding connections, and material is the polymer for insulations or porcelain. Seventh is tap changer. Allows to adjustment of the transformer voltage ratio by alternating the turns ratio of the windings. They have two types, off-load tap changer and on-load tap changer. Next, we move on to the EMF equation of a transformer. The EMF induced in the winding is given by E is equals to 4.44 Fn/m, where E is RMS value of the induced EMF. It is given by volts. F means supply frequency, SI is hertz. N means number of turns in the winding, and phi is the maximum magnetic flux in the core. It is given in Weber. Next, the power of transformer. High voltage. The power transformers handle very high voltage, typically in the range of hundreds of kilowatts volts. Power generation. They are used in power plants to step up voltage for efficient long distance transmissions. Then transmission grid. They are also used in substations to step down the voltage for distributions to local areas. Next, we move on to the transformers. Neighborhood power, voltage reductions, and distribution grid. There are three steps. In neighborhood power, they are found in residential and commercial areas, providing power to individual buildings. In voltage reductions, they step down high voltage from the transmission grid to lower voltage suitable for local use. Distribution grid. They form the backbone of the distributions network, delivering power to consumer. Next, we move on to the auto transformer. Here, the voltage regulations and phase shifting and smaller size. There are three steps. In a voltage regulation, they can increase or decrease the voltage by adjusting the tap point on the windings. Second, phase shifting. They can shift the phase of the voltage used in power factor connections and motor starting. In smaller size compared to the conventional transformers, auto transformers are generally smaller and lighter for the same power rating. Next, we move on to the instrument transformers. They have three steps: current transformers, voltage transformers, and protections and control. There are three transformers: current transformers, voltage transformers, and protection and control. Current transformers. They measure the high current by stepping down the current to a lower level that can measured by the instruments. The voltage transformers. They measure high voltage by stepping down the voltage to a self level of measurements. Protection and control. Instruments transformers play a critical role in electrical protection system and controls the circuit. Next, the transformer applications. First, it is used in power generations, transmission, distribution, and in industries we are using that. And transformer testings and maintenance as given pictures in below. Thank you.